So today's tutorial will be on empirical and molecular formulas. Now, molecular formulas are the actual chemical formulas given to you, such as CH4, C2H2. Those are molecular formulas. Now, an empirical formula would be the simplest ratio of the actual chemical formula. Hopefully, this definition will make more sense as we go through the different examples in the next few slides. So, here is the molecule for benzene. Benzene has a molecular formula that is C6H6. If you notice, there are 6 carbons and 6 hydrogens, so there is a ratio of 6 to 6. The most common number between the two of them is 6. So I can actually pare this formula down to its empirical formula. So the empirical with the smallest, simplest ratio. And I can pare it down to CH, where there's 1 carbon and 1 H, simply by just dividing by 6, which is the common number between the two. Now, you can also notice that the empirical formula is not the same as the molecular formula, but this is not always the case. Now, the next example I'm going to give you shows you that the empirical formula and the molecular formula are going to look the same. So here's the example. If you notice, empirical and molecular formulas can be the same. This is the molecule for methane, which is CH4, that's the molecular formula, and it has a ratio of 1 to 4, so there is 1 carbon and 4 hydrogens. The most common number between the carbon and the hydrogen is actually 1. So if I divide everything by 1, my empirical formula should still end up as CH4, a 1 to 4 ratio. In this case, I couldn't bring it any further down. I couldn't make it a simpler ratio because it is already at its simplest ratio. So here is an example where your molecular formula and your empirical formula are exactly the same. So let's go ahead and recap. Let's do a table where we compare empirical versus molecular. Now, empirical formulas indicate the smallest whole number ratio of atoms present in a compound. It is your reduced formula, that's the smallest ratio. And molecular formulas are the exact number of atoms that are present in the chemical compound. So it is your actual formula. Now, when you're doing your molar mass, the molecular formula, is going to equal your molar mass. The atoms sum up to your molar mass. Now, I just want you guys to make sure that you are comfortable with this concept of an empirical and molecular formula. So we're going to do a couple more examples. So here I've given you the chemical compound name, and I'll give you the molecular formula, and we're going to see how we can bring it down to its empirical formula. So the first example is hydrogen peroxide. Hydrogen peroxide has a molecular formula of H2O2. Now, the most common number between H2O2 is 2. And so I can divide this by 2 and bring it to its simplest ratio of HO. Now, hopefully this is making more sense and we can still continue. And so glucose has a molecular formula of C6H12O6. Now, this has a chemical ratio of 6 to 12 to 6. But the most common number between all 3 elements is 6. I could divide each one of these elements by 6 and end up with the simplest ratio of CH2O. Now, here's the next example, water. Water has a molecular formula of H2O. Does it have a common number? No, it does not, because there's 2 hydrogens and 1 oxygen. The most common number is going to be 1. So the final empirical formula, the smallest ratio, is going to be H2O because it is already at its simplest ratio. And my final example is going to be acetic acid. Acetic acid has a molecular formula of C2H4O2. The most common number between the two is, or between the 3 I should say, is the number 2. I can divide each one by 2 and end up with an empirical formula of CH2O. Now, I'm going to ask you guys to look at all these for examples. There is one thing that is really important for you guys to notice, especially in the empirical formula. You're going to notice that glucose and acetic acid have the same empirical formula, CH2O. This is something you need to know. It is a possibility that you will have the same empirical formulas for different molecular formulas, because remember, it is the smallest or the simplest ratio, so it's a possibility you'll have CH2O for another molecular formula. I could even multiply the whole entire thing by 8 and have a molecular formula of C8H16O8. So it's a really huge possibility that you can have a molecular formula that has the same empirical formula with a different molecule. And with that said, I hope this tutorial has been very helpful.